Remember that these sessions that we are doing at the moment are quick snippets of revision just for the theory, the stuff that you really are meant to know and to be able to get in those exam papers. And I'm hoping that you're copying them down, because remember, just watching passively doesn't make you a good mathematician. You need to copy it down, and then once I'm done, you need to go and look for more questions of the same type and practice them just to make sure that you've got the drift of the question. All right, guys, I'm going to spend the next 5 or so minutes just talking you through. It's from Learning Outcome 2, the Functions and Algebra Outcome, and it's finding the equation of a tangent. Now, of course, this is one of the things or the skills or applications that calculus allows us to do. What we need to have a look at and remember is that a tangent is just a straight line. So if they ask us to find the equation of a tangent, they are actually asking us to find something that will land up in the form y equals mx plus c. Now, I know that when I'm looking for the equation of a straight line, I kind of brainstorm it and I think, what am I really needing? Well, ever since grade 9, I know that I need a point that the graph goes through. So a point that lies on the line is most important. And then the other thing that I need is some information about the gradient of the line. Now, I know that most of you realize that from grade 9, whenever we've been trying to find the gradient of a line and we've had 2 points, we've always worked with the change in y over the change in x. But calculus comes along and it actually allows us to apply the fact that the gradient at a point is possible by taking the derivative. So what I'm wanting you to realize is that the derivative is actually the same as the gradient at a point, and it's also used for the gradient of the tangent at that point. Okay, so let's have a look at a kind of entry example. Not too easy. If we wanted easy marks in a paper, this is the kind of thing that we could ask. Find the equation of a tangent to y equals x squared minus 4x plus 2 at x equals 1. Now, it doesn't matter what kind of graph this is. It happens to be a parabola, but that is actually arbitrary. It makes no difference. What we do know, though, is that if it were to be drawn, it would be a happy parabola, and we are wanting the gradient of the tangent at x equals 1. So if we were to actually draw where x equals 1, if we were to put in a tangent wherever x is 1 is, this is how we're going to go about it. Now, remember I said that we need 2 things. The first thing that we need is a point. All right? Now, notice that they're giving us x is 1. So that means that the x value of my point is 1. But remember that a point has always got a double address system. So I need to know what the corresponding y value is. And I am going to substitute 1 into my equation. And so substituting 1 in, I'm going to get y value is going to be 1, take away 4, add 2. And you can see that that quickly comes to minus 1. 3 take away 4, minus 1. So the point that I'm working at, the point where my gradient has to be taken, is at the point 1 minus 1. So that's the first thing. The second thing I need is the gradient for my line. And I've told you that gradient amounts to the derivative. So let's have a look at our function. Our function was in the form y equals, so that means that my gradient at any point on this graph is going to be 2x minus 4. Now that's anywhere. Specifically at 1, because that's what I want, my gradient is going to be 2 times 1, take away 4, and that amounts to minus 2. Right, now I have absolutely all the information I need for my tangent. So remember I said to you my tangent is actually a straight line, so that means it must be of the form y equals mx plus c. Now, some of you guys have been taught an alternative formula, so we don't want to ignore it. It's y minus y1 is equal to m x minus x1. And we're just going to work these down in parallel to show you that both of them are equally appropriate. Right, so the equation of the tangent here is going to be y equals the gradient of the tangent, which we've worked out is minus 2x, add c. But now I need to substitute that all-important point that we know it goes through, which is 1 minus 1. So substituting the minus 1 in for the y and the 1 in for the x, I'm going to get minus 1 is minus 2 add c. And so finally, by bringing my 2 over, I'm going to get my c is equal to positive 1, which means my tangent is y is equal to minus 2x add 1. That means, guys, that I could have used the other formula, y minus the y value that the point goes through, which is minus 1, is equal to m, the gradient, minus 2x minus the x point that the line goes through, which is a minus 1. And I'm sure that you can see that y plus 1 is minus 2x add 2 by distributing that in. So getting it into the y form, I've got y is equal to minus 2x add 1. Okay, so it's not that difficult. They can vary the question just slightly in the following way. They could ask us to find the equation of a tangent to a graph, and of course the graph can be a parabola or a cubic, but I'm going to say find the equation of the tangent to y is equal to x squared minus 4x add 3, which is parallel to y equals minus 2x add 10. Now, can you see that I've varied things a little bit? There is my graph. I'm still wanting a tangent, but they don't tell me the point where the tangent is. They just tell me that my tangent is parallel to another line. Now, remember I told you that you need a point, all right, which at the moment I don't have, but you also need a gradient. And remember that we have a very vital piece of information, that the gradient of our tangent, the thing we're looking for, is parallel to this line, and the line has a gradient of minus 2. So remember that our gradient is going to be minus 2 as well, since the lines are parallel. All right? So I hope that you're thinking, all right, what can I do now? Well, remember, gradient is always derivative, and if I have a look at my function given, my derivative would be 2x minus 4. But now we don't know at which x value, so we can't substitute an x value in. However, we do know that the gradient is equal to minus 2. So can you see that? I'm bringing in this minus 2 because the gradient of my tangent is parallel to this guy of minus 2. So let's solve this out. So 2x is going to equal positive 2. So x equals 1. So what am I saying? I'm saying that if I had a parabola, y equals x squared minus 4x plus 3, and I wanted my my tangent to have a gradient of minus 2, it would happen when x is 1. Now, can you see that that's what is now aiding me to find my point? Because it's telling me that it's happening at x is 1. So, what am I needing? I now need that my point is 1. But what did I do last time in order to complete my point? I needed to find the corresponding y value, which means that I need to take my equation. If you recall, my equation was y is equal to, let's just grab it quickly. Oopsie, a little bit more. X squared minus 4x plus 3. X squared minus 4x plus 3. So substituting my 1 in, guys, that's going to very definitely give me y is 1 minus 4 add 3, which gives me 0. So this is happening at the point 1, 0. And there I am. I've got all the information I need. I can now go off and find my tangent, y equals mx plus c. And of course, I know that my gradient was minus 2. And then I can substitute my point in. So 0 is going to be minus 2 times 1 add c. C would be a 2. And I'm done because now my equation of my tangent is minus 2x plus 2. Okay, and that's really the basics of finding the equation of a tangent. And remember, it's linked to Learning Outcome 2, calculus, because you use the derivative in order to get the gradient of a point, which is the same as the gradient of the tangent.